Hello. So today's episode, we're going to be discussing the effects of radiation on human space travel. We're particularly concerned about chronic exposure, such as would be in a travel to the moon or Mars. We'll talk about the effects of radiation on the human body, as well as what countermeasures can be employed in space, and the research is ongoing for potential harm that comes to our astronauts as they travel in space and are chronically exposed to radiation. So let's get started. So this is a view of Mars, as seen from the Curiosity rover that has been released from NASA recently. As part of this series of the physiologic effects of human space travel, we're going to next move to the effects of radiation on the astronauts. We'll be focusing on both the short term and the long term, or otherwise known as chronic, exposure to radiation, such as we've experienced on a trip to Mars. In view of many space physiologists, radiation exposure is the potentially most consequential hazard to astronauts, and may be a limiting factor if we can not be overcome to achieving a successful space journey to Mars. Here you can see the craters of Mars, and hopefully one day we'll get there, but it has to be overcome by many factors, which we will discuss the research that's ongoing with that regard. As we look over the landscape in Mars, just know that the Curiosity rover is presently doing experiments with detectors of radiation exposure on the Martian surface, which will be very helpful in giving us a heads up on what to expect when humans finally land on this planet. So, first, let's talk about radiation in general, and then we'll discuss how it differs from radiation in space. The word radiation comes from the phenomenon of waves radiating from a source. These types of radiation are most commonly called ionizing radiation because they have enough energy to knock out an electron out of its orbit and around the atom. This creates an ion. We humans are exposed to many other types of non ionizing radiation, such as radio waves, microwaves, and sunlight in the form of UV rays. Radiation becomes a concern when humans are exposed to particles or electromagnetic waves that are energetic enough to damage DNA. This leads to cell death. Other indirect damage is caused by free radicals, which also damage DNA molecules. This can lead to cancer, but as we'll discuss later, there are other possible effects. The particles that we're discussing are alpha particles, which are helium nuclei, two protons and two neutrons. They are the largest and heaviest, but also easiest to protect against because they are easily stopped by a sheet of paper or a dead outer layer of human skin. Beta particles are fast moving electrons and positrons, which are much smaller than alpha particles, but are also easily stopped by plastic or deeper layers of skin. Gamma rays have no mass. They are pure energy in the forms of electromagnetic waves that have very short wavelengths and therefore much more energy than visible light has. Shielding gamma rays is normally accomplished by heavy metals such as lead. Only thin layers are needed to stop the vast majority of gamma rays, although some will get through. Neutrons are subatomic particles that are larger than beta particles and smaller than alpha particles but have no charge. While these characteristics make neutrons' radiation able to penetrate lead, neutrons are stopped by the water and concrete common in nuclear reactors. To better understand radiation exposure in space, I want to introduce some important concepts. As different materials that receive the same amount of ionizing radiation exposure may not absorb the same amount of energy, the gray was developed to relate how the different types of energy are absorbed. So the gray is the basic unit of the absorbed dose of radiation. It also forms the basis for the calculation of another important concept, and that's the unit, the sievert, which is a measure of the health effect of low levels of ionizing radiation on the human body. The sievert is intended to represent the health risk, which for radiation dose assessment is defined as the probability of radiation induced cancer and genetic damage, where one sievert carries with it a 5.5% chance of eventually developing cancer. In space, the sun is an important source of ionizing radiation in the form of high energy solar particles, which are normally trapped in the Earth's radiation belts, Van Allen belts, and by the fragile envelope of Earth's atmosphere. However, outside the Earth's protection, radiation from the SEPs or solar energetic particles, another source of radiation is the galactic cosmic radiation. These are composed of high energy protons and heavy atomic nuclei. These high energy, high charge particles in space can cause damage to both replicating and replicating cells. Ionizing radiation can cause damage to the cellular structure of its ribonucleotide DNA. In the International Space Station, the Van Allen belt protects from the galactic cosmic radiation, not the solar flares, which are omnipresent but can be predicted. On a space travel to Mars or the Moon, the astronauts are going to be exposed to galactic cosmic radiation for a prolonged period of time, and the effects can be significant. Of interest, in an astronaut that's on Mars, the galactic cosmic radiations will be lessened by the fact that the Martian surface or the lunar surface will act as a shield. So they only get 180 degrees of the galactic cosmic radiation instead of the full 360 on a Mars trip. So what can we do to prevent this? That's what we have to research further, because we don't want to exceed the half a gray or 1 sievert of exposure, which is limited to the astronauts at present. The factors that must be taken into account are age, gender, and smoking history, as women are more sensitive to radiation than men. So, what are the possible effects of radiation in space on humans? First and foremost, the concern is of cancer. We concerned that over time, astronauts exposed to the levels of radiation could develop cancer, but not till they get very old. The second issue is cataracts. This has been shown to be present in astronauts after even short-term exposure. This can be corrected with surgery, so it's less of a concern. The last is the endothelial damage that is done to the vascular tissues, which could cause premature hardening of the arteries and heart attacks. And finally, nervous system disease, whereby the astronauts could have cognitive impairment in space after a prolonged space travel. So what kind of countermeasures do we have to prevent radiation injury in space? Well, first and foremost, research is ongoing with the Orion capsules and using mannequins, which are called phantoms, which have materials that mimic human bones, soft tissues, and organs of an adult female. Their names are Helga and Zohar, and despite sharing the trip, their mission will be different. Zohar will wear astrorad vest, while Helga will be not. This will allow detection of radiation and difference in exposure protection from the astrorad vest. When it comes to solar flares, these are a particular problem for our traveling astronauts. However, they can be predicted by scientists, so when they arrive, the astronauts can take precautions to avoid harmful rays that come from this solar eruptions. Presently, the astronauts are instructed to use materials in this spacecraft to build a fort and protection around them to allow for them not to be exposed to the radiation. They can also wear vests and use electromagnetic radiation to block the solar flares and cosmic radiation. So what kind of research is being done by NASA with regards to radiation exposure in space? Well, on Earth, we can study radiation using the NASA Space Radiation Lab, which is located in Brookhaven National Laboratory in New York. What they do is they use linear accelerators to create these heavy ions that will boost their access to research by targeting these ions, which are many in different kinds, to animal models. The ions are fed into the collider and they're sped up and targeted towards animal models, such as mice. And with the exposure of these types of ions, we can ascertain what kinds of effects, such as cancer and other effects, will be caused chronically and acutely.
So, I hope you've taken away from this that radiation in space is a concern, but maybe not insurmountable, and research is ongoing to try to find out how the effects of radiation are going to impact our travel in space, especially to distances like Mars. So, thank you for joining us, and please hit subscribe so you can be notified of any more videos as they come along. Thank you for joining.